Now that we've talked about position and its relationship with time, the next thing we have to define is velocity. So we already know one thing about velocity. If you know position as a function of time, then you know that the velocity as a function of time is the derivative of that position with respect to time. And that's always true. That's one of those 5 key derivative relationships that I brought up at the start, and I'm going to keep bringing up. So this is just always true. Okay, if you know position as a function of time, getting the velocity is easy. What I want you to think about with the meaning of the velocity at a specific instant, so at any instant, the velocity means this. You can think of the velocity as being broken up into a magnitude, that's an absolute value, and a sign. The absolute value, the magnitude, is the speed. So you know what the speed means. That's just what the speedometer says on the thing if the object had a speedometer on it. The thing that your speedometer does not have is a sign. It doesn't say you're going negative 55 miles an hour. It just says 55 miles an hour. The sign is the direction that the object is moving at that instant. And so especially at the beginning, I want you to keep this definition of velocity in mind every time you hear it. Think of breaking it up into an absolute value or a magnitude and a sign and what the meanings of those things are. The SI units for velocity are meters per second. And so let's just go through a couple of examples that make you think in terms of this definition and this derivative relationship. Okay, so first, let's say we know that the position of a particle is given by the function 5t minus 3t squared. And the question is, what's the object's speed and direction at time t equals 6 seconds? Okay. Well, based on the definition of the velocity, we know that if we can come up with the velocity at 6 seconds, then the sign tells us the direction and the magnitude tells us the speed. So how are we going to come up with the velocity at time 6 seconds? We have the position as a function of time. So we're just going to use this derivative relationship. And so the velocity as a function of time is the derivative of 5t is 5. The derivative of negative 3t squared is negative 6t. Okay. That tells us the velocity at any time we want. We want the time 6 seconds. So at time equals 6 seconds, the velocity is 5 minus 6 times, plug in 6 seconds for the time. And you get negative 31 meters per second. And so now we can just read the values off. The speed, and by the way, often we'll denote the speed as a capital V. Why do you call the speed V instead of S? Well, it's just connecting the relationship between velocity and speed, and you often use a capital to talk about the magnitude of something. So anyways, this is often used to denote the speed, capital V. And the speed is equal to 31 meters per second. That's just the absolute value. And now what about the direction? Well, the object is moving in the negative direction because that's the sign of the velocity. Okay? Let's do another example that's maybe typical of what I would give you. So let's say that an object is moving in the positive direction with a speed of 5 meters per second. What's its velocity at that instant? Okay, well, the velocity is plus or minus the speed. And then the sign is the direction that it's moving. In this case, it's moving in the positive direction. So the velocity is just 5 meters per second. Okay, I've brought this up before, but I want to mention it again. The difference between knowing something as a function of time and knowing something at a single instant. We know this is the velocity at a single instant, but that doesn't tell us what it is over all time. So, like for example, could we figure out the acceleration by taking the derivative of this, and we would just get the acceleration is equal to 0? No, that does not work. If we knew that the velocity was 5 meters per second always, then that would be a function of time and the acceleration would be 0. But just from a single snapshot like this, you can't take that derivative. You can only do that if you have expressions for these things over all time.